So, hello everyone. Now we have to start our module 5, that is cloud networking and security part. In our last session, in our last module, we have completed our creating the account in cloud. Then we have done the provisioning of storage and compute. As well as last video, we done identity and access management basics. So this time we have to go a little more deeper in that with the networking part of cloud and security. Okay. So if we talk about cloud networking and security, refer to the technology, practice and architecture used to manage the network connectivity and secure the data in cloud environment. Means first, whatever the resources we are creating there, that should be properly communicate over the internet. That properly communications should be there between the cloud resources to the endpoint where the user trying to access it, and then securing the data in the cloud environment, either that is on the server or on the transit, means on the way or on the internet, on the wire, moving from one place to another place. That can be from user to server or within one application to another application. Security is the prime concern. First connectivity and then security. Okay, now let's have a breakdown in detail about the networking and security part. Networking, as I have already discussed, involves the designing, implementation, and management of network infrastructure in cloud environment. Design that, implement, and after implementation to manage that connectivity properly with the client or customer or any endpoint. That can be your AWS, that can be your Azure cloud, or that can be your Google cloud. These are the major cloud providers. Each enable the communication between the cloud resources and the user. That is the networking. Earlier we have already discussed about something about VPC and other parts. So let's go some more deeper in that. I will show you the practically also in the console. So the core concept, very first thing is the VPC. Isolate network within a cloud provider. So very first thing before creating the resource is the VPC. Inside that VPC you can create a resources. As I have explained you already, it's just like a, you can say, a building. Within the building, different apartment there. Within a building, different apartment there. Means this is my house, this is my apartment, this is another apartment, this is the another one apartment. But these apartments are isolated from each other. Whatever I'm putting here, what I'm doing here, how I'm decorating it, that totally depend on me. It does not interfere with another apartment. So in the same way, in a cloud, we have to create my own isolated network or data center, you can say. It's totally my data center. I can do whatever I want to. I can implement any type of routing there. Routing means set up my routing table. Okay, can create my NAT gateway. Can use the CIDR or subnets according to me. I have to design this. So totally isolated network within a cloud provider. Then comes the subnet. segment a VPC into a smaller network. Let's come to demonstration. I think I'm logging to the console here. Yes. So if you remember, if I go to networking section, I want to show you. Otherwise, if I show you here in EC2, whenever we create a EC2, if you remember last module, we have done that practically. Launch an instance, taking some time to download, to open the console. Okay, so you can see here on the downside in the networking settings. Just a minute, just a moment. Look here, you can see the option of VPC, you can see the option of subnet. Okay, if I choose here, I want to use window. Okay, in window I can choose the server according to my requirement. Then little slow, sorry for that, but not sure. Okay, here you can choose the instance type. Now you can see here when we go to the edit part of this, right now it is showing me a default VPC. It does not have any another VPC. After the VPC, you can see here is the CIDR range of 172.31.0.0/16. By default, you are getting this. Then different subnet there with different CIDR range. Please watch very carefully here. Each subnet have different CIDR. This is the main CIDR that we have chosen with /16. What I'm expecting you have a good knowledge of IP addressing and subnetting. Basic IP addressing and subnetting. We don't want to go with much detail in that. So here the main ICIDR range has been chosen 172.31.0.0/16. Again, that subnet means divide that VPC into small subnets with different CIDR range. We divide that big IP range into small subnets. Subnets means to break a big network, create a segments into a big network into smaller. So you can see everything you have to fill it here. Remaining we will discuss all the point here. You can see by default it's a VPC, default VPC. But if I duplicate it, I want to show the VPC option here. How you can create a go to all services. Then I go to networking section here. Networking and content delivery. Here you will find the option of VPC. Whenever you create an account, one default VPC will be there. But you can create your custom VPC also there. Default VPC will be there, default subnet will be there. So when we go to the look here, we are right now in the Europe, Stockholm. So one default VPC is there. You can see we don't do anything on the here, and subnet is 3 subnet by default here. But when we create VPC, so you can see here it will ask what IP range, what CIDR range you want to use. Okay, and after that, when we create a subnet, you can see the option of subnets. We can divide that particular CIDR by default 3 subnet is here with the default VPC. Then we can manage our routing table. Then we can create our internet gateway. So everything is there that I want to show you. So first we create a VPC in like AWS Google Cloud, AWS Cloud. Then break that VPC CIDR range into small networks that is called the subnets. And then we configure our routing table, direct the traffic within and outside the VPC. Routing table is an entry table that if I want to send this traffic, how and where I can go. If I have to go out from this building, what is the main gate? If I have to move within this building, then from which gate I have to go. There is a complete table there. Let's see. To go to the route table, if I check it, you can see here, select it have a look 000 connected with the IGW stand for internet gateway. If our traffic need to go outside of the VPC, and this is my local route. So all the routes should be here within the routing table. So that is a routing table. Internet gateway, when I need to send the traffic from my VPC to the internet, then either we use the internet gateway or we use the NAT gateway. NAT gateway, like when we discuss about the private subnets and public subnets, when I need to send the traffic from private subnet, either we have already discussed in previous module also. NAT gateway to enable the communication between private subnet to the internet. Then we use the NAT gateway. For public IP series or public subnet, we use the internet gateway or any type of internet communication. NAT gateway also forward the traffic to the internet gateway finally. So provide the internet access to the cloud resources. Then load balancer. These all are the component of network. Distribute the traffic across the multiple server for the performance and availability. Load balancer. By the name itself, it's clear. If much traffic is coming as expected, I have too many server here that is within my VPC. Okay. So if more traffic is coming, rather than putting the load on single server, it can be distributed among multiple servers with the help of a load balancer. That is a for performance, so that performance should not be down if more traffic is coming and should be available. If in case one of the server goes down, no doubt problem, we have the another server available. Then VPN and direct connect. Secure connection between on-prem and cloud network. VPN, virtual private network. One of my clients is sitting here in Singapore. My main server is in the Mumbai region, or my server is here. So when I want to enable the access that my client that is in the Singapore want to access this server, so I cannot afford that it go via open internet because it is unsecure and we can hack here the data. So security concern comes. In that case, we use the VPN, virtual private network. That is even tunneling. We create a secure tunnel here over the internet. We create a secure tunnel here over the internet so that my data travels securely between client or on-prem to cloud network or any client to server. For that purpose, we use the VPN. That is a part of security, you can say a little bit. Then DNS. Route 53 is the service from that is known as the by the AWS provider. AWS is Route 53, but basically that is a DNS, domain name system, to resolve name to IP address. I think you all are familiar with this term. If you're thinking about the cloud computing, so these are the very short terms. DNS is the first thing that every IT person should know. What is the use of DNS server in our network? Normally we type the www.google.com. Google is a name, but actual communication over the internet happen with the help of IP address. So first it resolves the name from Google to its IP, then the communication starts. So these all are the part of networking. Okay, so these are the core concept in networking that should be familiar. I have shown you practically that on the console also, that we have to configure everything to make a perfect networking environment. Then the concept of cloud security. By the name clear, whenever data is there, it should be secure. Encompass tool, technologies and policies, practice to protect cloud data, any application or infrastructure from any kind of threat. I don't want my application corrupted or whatever the data there, either in the server or on the transit, on the way from user to server, or from my on-prem to my cloud server. In case of hybrid environment, here are the concept identity and access management. Already we have discussed this little bit in our previous video. Define who can access what resources. Who can access what resources? Like when you log in into your Gmail account, you got your own mail, not the mail of your friend or any person. When you log in with your credentials, you only get your mail, your photos, your drive, everything get your own, none another. So in the same way, when any of my user log in into the cloud, it should get on services. He is able to eligible. He is eligible only for the EC2 access. He is eligible to manage the S3. And what he can do with the S3? He can create the S3, or he can view only the S3. Then second concept of the security is the encryption, to protect the data either at the rest or in the transition using encryption. Okay. Rest means when data is in the server or in storage part, not moving anywhere. And in transit, when data is moving from like my on-prem to my cloud server, that is a transit on the way anywhere, even from one application to another application also on the transit. Then using the forward security group. These are the core concepts for the security. Control inbound and outbound traffic to the instance of service. Inbound means incoming traffic from anywhere, any request coming there. Outbound, any data go out of my machine, where it is going, why it is going. Inbound, why this person want to come into the server, what he want to do. Either he want to access the file, he want to access the application, I want to ping or telnet or remote access, anything want to do, that we can control with the help of inbound and outbound traffic. There is a firewall and security group. Then security monitoring and logging. That is a must part. Server is going smooth, no issue, but monitoring is must. And logging. Log should be there properly. Who entered, what he did, how long he was on my server. Everything helps with the help of log. So tools like CloudTrail, CloudWatch in case of AWS cloud, Azure Security Center for editing logs and real-time alerts. If something happening malicious, some attack is there, So that is the monitoring tool. So compliance is must. There is a long listing of compliances, adherence to the framework like GDPR, General Data Protection Regulation, and SOC. These are the organizations who create some framework for the security, for data security, for any type of data security. GDPR is like General Data Protection Regulation. So we have to follow the guidelines as per GDPR, SOC, and one more like medical facility. I don't remember the name of her. So compliance adherence is must for the security. So tool and services by the provider, by the AWS networking tool, we have already discussed this. VPC Route 53, ELB, Elastic Load Balancer, we have discussed already, and Direct Connect or VPN also. For the security, IAM, KMS, Web Access Firewall, Guard Duty, Call Trial, these all are the tools that we use in the cloud environment for security. In Azure, it becomes virtual network, Express Route, or Azure DNS. Security is the Active Directory, Key Wallet, and Security Center. GCP, it's again VPC, Cloud Load Balancing, Cloud Internet Connect for the connectivity. Here also IAM for the security. One is the Cloud Armor, Cloud DLP, and Security Command Center. These are the different tools in the cloud. This is the comparison of different tools. So best practice for the security, follow least privilege principle in the access control. When we are creating IAM user, we have to create the IAM user. So providing the least privilege means limited resource access, only whatever the user required, give him the privilege to use that, not give him full access. For login purpose, we use the multi-factor authentication MFA for all accounts. Encrypt sensitive data at rest or in transit. Regularly audit and rotate the credentials. We get the message from the Google also after some time, after 90 days, change your password for the security reason. These all are the best practice that do. In case of container, security check with CI/CD pipelines. Network segmentation using the subnet. Use the private subnet where appropriate. Maximum try to put your resources in the private subnet for the, because private subnet directly cannot communicate over the internet. No inbound request accepted for the private subnets. If anybody try to access private subnet directly, that's not possible. Only outbound request is generated here. Inbound is not possible. So naturally set up the alerts for unusual activity using the same or cloud native monitoring. Like I've told you, in AWS, a Cloud Watch, Cloud Trail, many other tools. So either we have already discussed all these things in fast overview again. VPC is an isolated virtual network within a cloud provider. It have like on private data center, but in the cloud. Subnets, you divide the VPC into the subnet, private and public subnet. One is the private subnet where resources in the private subnet cannot directly go to the internet. Public, the device or you can say servers that need the direct internet access. Routing table, traffic flow within the VPC or to or from the internet. Internet gateway for public subnet. We connect one internet gateway with the public subnet so that it can go to the internet. the any resource within the public subnet to go to the internet, use the internet gateway. And NAT gateway it used for private subnets. In some cases, like we have to update the patch update, software update. In that case, this server in the private subnet needs access to internet. So read carefully, NAT gateway for outbound internet access from the private. It is always request created from the private is outbound. In that case, request go to NAT gateway, and NAT gateway route the traffic to the internet gateway, and then it goes to the internet. So internet gateway directly for the public subnet and NAT gateway for the private resources. Okay. Key feature of VPC isolation. I have already told you that is isolated from other within the same cloud, from the other network you can say, or another data center, another organization should be there, because we are not the alone that are working on the AWS cloud. Thousands and millions of customers are there. So isolation is the one part or feature of VPC. Custom IP range, you can define your own IP series there. Subnet, then we create the subnet, we do the routing, and we configure the internet gateway. All things have been discussed already and shown you in the demonstration also. NAT gateway instance for the security, we use the security groups there. We use the NACL, that is a part of VPC. VPC, when we discuss detail of the VPC sometime, then we discuss it. Security group at the instance level for each device within the cloud, within the subnet. NACL work at the complete subnet. There can be 10 devices, there can be 100 servers. So network for the entire network, entire VPC there, and security group for each device. Like you can see here, where is the, if we go to the VPC EC2, in which security group we can configure the security group individually there. Instance. Taking some time, no problem. Launch instance. Look here, security group option is here. Here we can add rules. What is allowed? What is not allowed? Look here. I want to allow SSH traffic. Okay. So we can, I want to allow HTTP traffic. I want to allow HTTPS traffic, or what I want to configure, I can do it from here. Which type of traffic is allowed? Clear? Everything is here. Network, subnet, and this is the public IP that I'm going to discuss. Here is the firewall. Here is the security group. And then we can do the peering. Can do the peering using on-prem network, or to the on-prem using the VPN and direct. Peering means one VPC, my one VPC, my organization one VPC is there in suppose in Europe and one is in the India. I want to peer them so that they can communicate directly without going to the internet. Some resources are here in India and some resources in some another region in another VPC. So we can enable the peering so that they can communicate with each other without using the internet. That is a pairing concept. Use case, all are the use case: hosting secure web application, hybrid cloud environment, isolating the environment, setting up microservices architecture. Everything we do within the VPC. We already discussed this. These are the different. Tighten the integration with Azure Active Directory in case of Azure. Simplicity and ease use. Best is the GCP. Fewer components to configure. Global architect reduce the complexity. But most commonly used is the AWS cloud due to the granular security control and can do the complete customized network using the security groups because of security groups, granular security control and NACA. Rich routing control there in the AWS. That's the main feature why AWS cloud is most preferred at the top nowadays due to security feature and rich routing control. Okay, if we talk about the firewall, already basically we have discussed offer a service called cloud as a firewall as a service, that FWAS are the security solution hosted in the cloud that monitor and control the incoming and outgoing network traffic to protect the cloud infrastructure, application, and data. So for any type of security is the firewall. Firewall options within the each provider. AWS, it uses security group. I have shown you practically on the console also. It uses the NACL, network access control list, network firewall. Why? Web application firewall at layer 7 to protect your data, your infrastructure from any type of attack. In Azure, it is known as the NSG, Network Security Group, Azure Firewall, Firewall Premium, and WAF also available. So these are according to the different providers. Purpose is same, but they use the different. So cloud firewall, global rule apply, hierarchical firewall policy, cloud armor, L7 protection, layer 7 protection. In case of AWS, what we are saying web application firewall, that is also for the layer 7 protection, and serverless VPC firewall access. So it is a summary, already have discussed, no need to repeat again and again. This is the architecture. Here is the network firewall, virtual network, entire VPC. Inside that, we use the public subnet, private subnet again and again, and then connect to the internet. Subnetting in case of VPC is must. If we talk about the IP addressing, I will not discuss about that basic IP, that is the 32-bit address divided into the 4 octet, then private IPs, then public IP range is this. Not so much time. I just come directly type of IP addressing in cloud. So in cloud computing, IP addressing is how virtual machine or container or other resources are assigned unique address for communication over the network. Just like a traditional networking, but with added flexibility and scalability. So one is the private IP address. Here also private IP address available. Same IP series that was the use. Like for A series A class 10.0.0.0. For B class 172.16.0.02, 172 dot sorry dot 31.255.255 IP series, and 192.168.0.02, 192.168.0.02, 168.255.255. These are the private IP series that are not able to communicate over the internet. That is only for the personal use. So used for communication within the private virtual network, cannot go over the internet, not accessible to internet. Automatically assigned by the cloud frame, that is the help of DHCP or Palm service. It is used for internal services, database, etc. So please, if you have any doubt, please revise or update your IP addressing. Basic IP addressing, where is the private IP is used and where is the public IP used. Then public IP used for communication with the internet. So it can be ephemeral or dynamic, assigned, temporary, or static, reserved and persistent. Charges may apply. Used for web server, API and load. Here you can, one is the ephemeral dynamic. Whenever you create, whenever you create uh, any, you can say resource, you can say auto assign public IP, auto assign public IP, sorry, public IP. So any resource in public subnet should be enabled. So whenever you create a resource, AWS or any cloud provider automatically assign one dynamic IP here. There are two type of IP you can assignment na. One is dynamic, one is the static. Static IP also called you elastic IP. You can also purchase one of the elastic IP, and that will always remain in your account. Either your resources goes, okay, but still that IP remain reserved for you, and that is like a elastic IP option. You can purchase permanently for you. Either you delete the resource in case it is a dynamic IP. I have shown in case of EC2. If you delete the resource, that IP automatically get released. But if you purchase one of the elastic IP, that is always remain in your account. Allocate elastic IP address. Right now, not. I am not going to purchase it because it is a chargeable. It always either it is connected with any resource or not, but it remain with your account, and you have to pay for it until unless you release it manually. Until unless you release it manually. So that is the dynamic IP known as ephemeral IP. Static, reserve and persistent, that charges may apply. You have to pay the money for that. Elastic IP, also known as elastic IP. This one. A static public IP address that can be remapped to a different instance. Okay, that is with your account. You delete one instance, you create one more instance, you can remap that. But in case of previous auto assigned, your uh, you delete the resources, that IP got released. You cannot get the same IP for another instance. So you keep the same IP even if the instance change. That is the elastic IP. DNS, I have already told you, DNS itself have a IP there. Cloud platform often provide internal DNS for easier communication. AWS give EC2 instance a DNS name like this when we configure the DNS or S3 service. And CIDR and subnetting, I think everybody know, classless inter-domain routing to create a big network into small IP range. When you're creating a virtual network, I've shown you, first we create a VPC. Inside that, we create subnets for logical segmentation and control. So given the question to you, please go for some IP classes where you learn about the subnetting in detail. Security consideration: use private IPs wherever possible to reduce the exposure. Use firewall, security group, and network ACL to control the traffic. Avoid using the public IP address unless absolutely necessary. This is security consideration. Okay, so here we discuss everything about networking and security component like firewall. We discuss about VPC. We discuss about subnetting, why we use, what is the use cases of all these things, IP addressing. This all we have done, and then we have done the security consideration. This all we have done in this video. In next video, we'll start with next topic of node balancer and other topic. So thank you very much.